Hey, this is Atara, your TA, and I'm going to make a little video explaining NHST and power. First of all, I have to apologize. I'm in the mall because that's where I usually work, so it might be a little noisy in the background, but I hope that you can still hear me and that everything's okay. Okay, so I'm first going to start with power. I sent out a chart that I made when I took this class as a freshman. That like all my friends wanted copies of, so I figured that you would want it too. And I'm just going to go through it because I think it summarizes power pretty well. So at the top, it says, I need to evaluate my null hypothesis. Where do I begin? So it's very important to understand that power is really like your power. It's the power to understand what you're researching and the power to get the result you want, which is rejecting your null hypothesis. The null hypothesis is annotated like this, H0, and alternative hypothesis is like H and then a 1 subscript. But right now, we're really going to mostly focus on just rejecting the null hypothesis, especially because that's what we use in NHST. So, okay, let's say we have our data, and we want to, let's say our data falls in this region, okay? So let's find the color that correlates to that region, okay? So this is a pretty big region of data. And it's on the side with the null hypothesis, so it looks like the data is going to match up with the null hypothesis. And it turns out that I'm right. So then we would go under not rejecting our null hypothesis because this data supports our null hypothesis. Look at the left of the chart. Are you right? Yes. And that's how you calculate knowing how like what the data is for not rejecting your null hypothesis. Now power, so that was just a little example. Power is what you have all over here. And that's 1 minus beta. So really what you want to do is you want to find data points that are in your power region because that's really what you want in terms of your results. And so we really want to maximize this area as much as we possibly can, the area with the alternative hypothesis where we can reject our null. So in order to do that, just find the page in my notes, 1 second, because it also has a nice little drawing there. Okay. We want to increase power as much as we possibly can. So here's the chart again with the distribution and everything. Okay, so how do we increase our power? Well, power is 1 minus beta. And we're looking at this side of the graph. So we want this part to be the biggest it can possibly be. We want this to be small, the smallest it can possibly be. We want this to be the farthest over there it can be because we want our power region to be huge. So if this is 1 minus beta and this is alpha, if we increase alpha, then we can move this line. I wish I had a whiteboard, but I don't. And we can move this line farther over here and therefore increase our power. However, we also increase our alpha region, so it also increases the probability of getting a type 1 error, which we don't want, but it could be worth it. As long as you increase alpha to a normal degree and not go crazy with it. Like you can't have alpha be like 1.3 because that is a huge, huge region and really anything will fall under it, especially because it's over 1. So you really don't want to do that. You can also make it a one-tailed test, which will increase alpha, which will therefore increase the power. You can increase the sample size. I think Dr. Tomlinson spoke about this in lecture, but I just want to reiterate it. If you increase the sample size, then it's like how if you take an exam and let's say you take an exam, there are like 50 questions and they're all multiple choice. Each question is worth 2% of your grade, you can get 5 wrong and still get an A. Now let's say that you have a test with 2 multiple choice questions in it. Yeah, it sounds easier because it's a shorter test, but it's actually a lot harder to get an A on that test because you have to get both of the questions correct. So if you increase your sample size, just like increasing the number of questions on your test, then you have a greater chance of having power because there's less variability and it's more of a normal distribution. And also assume a larger effect size because you don't want to be like plotting every teeny tiny little thing and it'll just increase your power. So now we're going to move on to NHST. Okay, so I think that the best way to describe NHST is with an example. Okay, this is an example that I did in class when I took Dr. Tomlinson's class. So I'm just going to read it out to you now, and then we'll do it together. The professor, there's a professor who's been teaching for a while. His records show, here, I'll show you. This is 82, 10, and 10. He thinks that his students are better this year than they usually were. Okay? His class has 65 students, and the mean is 87, which is the X with the bar. Is he right that that his students are smarter than they were in previous years? So, the first thing that you want to do is, wait, hold on one second. Actually, give me 1 second. Sorry, I know this is weird. Okay, so if the mean of his population, which is mu, is, sorry about that, my friend just texted me. If the mean of his population, which is like all of his students forever, is 82, which is what I showed you, and standard distribution is 10. So his null hypothesis would be that his students' mean is going to be less than 82, okay? Because 82 is the mean of all of his students forever. So that could go back to, like, he's been teaching a really long time. So let's say, like, he started in 1997. That's when I was born. He started in 1997. Since then, it's been 20 years. This is his 21st year teaching. His mean of all of his student scores was 82. Okay, that's pretty high for a professor, but he thinks that this class is exceptional. But what he really needs to do is to reject a null hypothesis. What you just want to do is say that you're not wrong. You don't necessarily have to say that you're right. Rejecting a null hypothesis is all about not being wrong. So the null hypothesis is just that their sample is less than 82. The sample mean is less than 82 or equal to 82. That's it. Because you just want to say that it's not more than 82. Because if it's more than 82, then that rejects your null hypothesis. You just want to say that your hypothesis, your alternative hypothesis is not the case, and that's your null. So your null hypothesis would be, my students are not better this semester than they usually are. Their mean is less than or equal to 82. Okay? Your alternative hypothesis would be that your students are better than they usually are, and your mean is greater than 82. Okay, so that's the first step. The second step is, I'm sorry, I'm really tired, but I still want to give you this, and please tell me if I'm not making any sense because I am really tired. 1 second. Sorry. Okay. So, The next thing we want to do is we want to set the decision criteria. So alpha, we want to set alpha to 0.05. Alpha is always 0.05 in this class. You will never have alpha not be 0.05. That it should be your easiest part of NHST because alpha is always 0.05. Write that in huge letters in your notebook, underline it, bold it, do whatever you can. Alpha is always 0.05, okay? And because we're just saying that they are better or they are not better, this is a one-tailed test. Because if they are better, we're only looking at if they are better or not. We're not looking at whether they are different. We are looking at whether they are better. Do you see if there's a difference? If they were different, let's say like the number 82 is different than the number 81. It's also different than the number 83. If we are looking at difference, then it would be a two-tailed test because 81 is less than 82 and 83 is greater than 82. But we're only looking at whether the students are doing better. So we're only looking at the number 83, which makes it a one-tailed test. And this is a normal distribution case. Okay. Next step, we want to obtain our sample data. So our sample size is 65 students. Our mean is 87. How did we measure the data? We measured test scores, and we drew our normal distribution with the critical region, and our mean in the middle. Okay. Now we need to calculate our test statistic. In this case, we are going to use a z-score to find our statistics because that's the most appropriate for this data. So to calculate a z-score, you already know how to do it. Mu minus the mean of the population minus the mean of this sample over the standard distribution over the square root of the sample size. And so that we get 4.03. Then we go to our z table to check what 4.03 is. And it turns out that our p-value is 0.0000, which means that there is absolutely no way. I mean, there's a teeny tiny fraction of a chance, but like there's really no way that you could be wrong about this. Your null has been completely rejected. It is done. This class is clearly much smarter than everybody else, and you were wrong to think that they are not smarter. But that's the most important thing to say. You are wrong to think that they were not smarter. You weren't necessarily right. We don't know if you were right or not. We think that you were right. But that's not what NHST does. NHST just says that the professor was not wrong when he thought that his students do better. And that is how you do NHST and alpha. So please let me know if you have any more questions or if I spoke too fast in this video or anything. I'm usually face-to-face with students. So please let me know if you have any more questions or if you want me to record another video, and good luck.